In this video, we are going to talk about the other method to solve for a system of equations. So again, we're trying to find the intersection point between two lines. So this is where x and y values are the same. So when we use elimination, we do this when we're in a situation where we are not given either line in y equals mx plus b form, which we've seen previously for equal values method and substitution. So we have to do some manipulation in order to make this work. Usually this involves either addition or subtraction and sometimes multiplication or division as well. So in this first one, notice a couple of things. This one is 7x and this one is 7x. So I want to identify if there's a variable that I can subtract or get rid of somehow. So I have to make the decision, do I want to subtract the top equation or the bottom equation? And I can do this as it's stacked like this. So I'm going to rewrite it though, just to make it a little bit easier. I have 7x plus y equals negative 26, and I have 7x minus 6y equals 9. So if I want to get rid of x, because that would probably be the easiest, I want to be able to subtract 7x from 7. So I'm literally going to be subtracting straight down. So I want to subtract this entire equation from the equation above. So that I don't make a mistake, the first thing I'm going to actually do then is distribute this, what's actually a -1, into every single term that's in this equation. So I'm going to rewrite this. So I have my 7x plus y equals -26 still, but I'm going to distribute this -1 into here because I'm less likely to make a mistake if I do this now. So then I end up with -7x plus 6y equals -9. So this allows me now to actually add straight down instead. So by adding straight down, you'll notice 7x minus 7x, that's gone. So now I can just add straight down here and I get 7y. And then if I add straight down here, I get -35. Well, now I only have one variable to solve for, which makes it so much easier. That's our goal, right? To find one variable. I want to get rid of the other variable because it's too much going on, and I want to be able to find the point of intersection. So from here, now I can just isolate y by dividing by 7 on both sides, and we get y is equal to -5. So that we're partway there. The next thing I need to do now is still solve for x. So it does not matter which equation I'm going to plug into. I need to plug this y value back into one of these so I can solve for x. I'm personally going to use the top one. So that means that and I'm just going to make it so you can see the distinction. For y is equal to -5, I'm going to replace my y value in my first equation with -5. And that's equal to -26. Now I want to get 7x by itself. So that means since this is -5, I'm going to add 5 to both sides. And that leaves me with 7x is equal to -21. Since 7 is being multiplied to x, I'm then going to divide both sides by 7, and we find that x is equal to -3. So my final answer then for the point of intersection will be -3, -5. So this is what we're looking at. So there are other instances that can come up where I can't simply identify a way to either add my equation straight down or subtract from my equation straight down. And it happens when I'm trying to find, well, I want to get rid of x or I want to get rid of y. But the coefficients or the numbers in front of my variables are the same. So notice that. They're not, these ones are not the same. So I can't just subtract. It means I have to multiply. So I want to get rid of one of these variables, I need to multiply by some number so that it matches the one on top. The easiest way to do this is to identify which variable has a number in front where it's easy to multiply by. So I can see that 9 and 18 are probably going to be easier because 9 times 18 or 9 times 2 is 18. So whenever I multiply any equation by a number, it doesn't actually change the line itself. So you can look at that in Desmos if you want, but the line itself doesn't actually change. So we're not changing anything. We're actually just scaling it so that it matches, but it's still the same line. So what I'm going to do here is I'm going to multiply this equation not just by 2, but -2, since I know that these are both positive and I want these to be opposite signs. So when I multiply every single term in here by -2, I end up with -18x plus 4y is equal to positive 12. So now, if I rewrite this on top of it, 18x plus 7y is equal to 21, you can notice that now I can add straight down and get rid of one of these variables. So this is now gone, and I'm just left with the y's to deal with. So if I add straight down, I get 11y is equal to 33. From there, I'm going to divide both sides by 11, and I find that y is equal to 3. So similar to the previous one, I'm going to plug this into one of the equations that I have in order to find my x value. So for y equals 3, I think I'm going to choose actually using the second equation as it is, was 9x minus 2y equals -6. I think it's a little less or a little easier multiplication. So 9x minus 2 times 3 is equal to -6. So then I get 9x minus 6 is equal to -6. If I add 6 to both sides, I end up with 9x is equal to 0. This is okay. It's okay when things equal 0 because then when I divide by 9, it just means x is equal to 0, and that's okay. X can be 0 and y can be 0 in other cases. So my final answer as a coordinate would be 0, comma 3.